Hello and welcome. Mr. Johnson back with you, and in this video we're going to be looking at stoichiometry in the mole roadmap. So let's go on and jump right on into it. So first off, as always, we need to define what exactly it is that we're talking about. So stoichiometry is just a really fancy word for math whenever we're doing this with chemistry. Strict definition is the careful quantitative analysis, in other words, mathematical analysis of substances involved in a chemical reaction. And when we look at stoichiometry, there's basically four types of reaction stoichiometry problems that you're going to encounter in chemistry. Anytime that you have a stoichiometry problem, it's always best to think about these problems in terms of what you're given and what it is that is wanted. Okay? Because we're going to be doing conversions. And if you haven't done conversions before, I would highly recommend you stop this video and go back and look at one of my earlier videos where I show you how to do grams to mole conversions, mole to mole conversions, moles to particles, and things of that nature. Okay? That's going to get you set up for this video. But if you already know how to do simple conversions of grams to moles, moles to particles, etc., then you're in good shape, because all stoichiometry is the incorporation of those concepts with a balanced equation so we can go from one substance to a different substance. So in going from one substance to a different substance, again, four basic types that you're going to run into. The first of these is when you're given moles and you're wanting moles, or they start you with particles and you're wanting particles. Second type is when you start out with moles and they're asking you to calculate grams or particles. Third type is they're going to start you out with grams or particles and they're going to ask you to calculate a certain amount of moles. The fourth type is when they start you with grams of one substance and ask for grams of the other substance. And all of these four types of problems revolve around this thing called the mole roadmap. Now, you're going to see this in textbooks lots of different ways. All right. Some of them are very basic and only show grams to moles and moles back to grams. Others incorporate particles and volume. The one that we're going to use for this video is this one that just shows grams, particles, and moles. At the end of this video, I'll show you the complete roadmap that also includes volume. Okay? But we're not going to work any volume problems today because in essence, they're the exact same as mole to mole or particle to particle. And I'll show that to you at the very end. So let's delve a little bit deeper into this mole roadmap with these four type of problems that you can encounter. So again, the first type is this mole to mole or particle to particle. And if you look at the mole roadmap, if I start at moles of A and I'm trying to go to moles of B, only thing I need is a balanced equation. So real quickly, if you don't know how to balance equations, again, I suggest you stop this video for the time being and go back and watch the video that I've made on balancing equations. Once you know how to balance equations, or if you already know how to, then you're ready to go for this. Okay? But if I start at moles of A, go to moles of B, all I need is the balanced equation. Same thing if I'm starting at particles of A and I'm going to particles of B. Notice that the two conversions as I go from moles to particles and particles to moles, these are just inverses of each other, which means Avogadro's number would cancel out. So if they start with particles of A and want to find particles of B, all I really need to do is apply again that ratio from the balanced equation. For the second type, moles given going to grams or particles, I'd start at moles of A and I'm going to use that balanced equation to calculate my moles of B, and then either use the molar mass to calculate grams of B, or since I'm sitting at moles of B, I can use Avogadro's number to calculate the particles of B. Now, again, if you don't know how to calculate molar mass or what Avogadro's number is, I suggest once again, you stop this video and go back and watch the videos that I've already made on calculating molar mass and atomic mass. I explain how you do molar mass, how you deal with Avogadro's number. And again, once you know those things, you're going to be in better shape for this particular material. Third type, though, is when you're given grams or particles and you want moles. This is just the reverse of the second type. We're going to start with grams and use molar mass to find the moles, or start with particles, use Avogadro's number to find moles. And then the third type, or the fourth type, is when you start with grams of A and they want you to go all the way to grams of B. Well, in that case, we're going to start grams of A, use the molar mass to find moles of A. Once we know moles of A, use that balanced equation to find moles of B, then the molar mass of B to find the grams of B. So this is how we use that mole roadmap. And my hope is that eventually you become well enough versed in doing stoichiometry problems that you don't really need the mole roadmap. Instead, you can think about it in terms of canceling out units like we do with any other type of conversion factor. Okay? But let's go on and take a look at some examples of stoichiometry. In going into these examples, I want to let you know that this is the periodic table that I'm going to be using. I've linked this periodic table in a previous video. I unfortunately don't remember which video it was, but I believe it was the calculating molar mass. If not that video, then it was the converting. I did 3 videos: grams to moles, moles to moles, moles to particles, and I'm pretty sure the periodic table is probably linked in one of those videos, if not the molar mass. But this is the periodic table I'm going to be using, so please make sure you have out your periodic table and make sure you've got out a calculator to be able to work these problems. So let's go on and start with probably one of the easier types, because all we're doing is a balanced equation with this, and do a moles of A to moles of B. So we're given this equation: magnesium reacts with phosphoric acid to produce magnesium phosphate and hydrogen gas. And the first thing we have to do is balance this equation. And again, if you don't know how to balance equations, go back, watch the video that I've made on balancing equations, and get up to speed on that. So the first thing I'm going to do is balance out my magnesiums. So I need a 3 on the reactant side. So I've got 3 magnesiums equaling the 3 magnesiums on the product side. My hydrogens, I want a 2 in front of the phosphoric acid to give me 6 hydrogens. And on the product side, I would end a 3 in front of the hydrogen gas to give me 6 hydrogens. And when I look at this, I now notice that I've got already, if I envision unwritten parentheses and unwritten 1 behind that phosphate, I've got 2 times 1 for 2 phosphate groups, and on the product side, unwritten 1 times 2 to give me 2 phosphate groups. So this is balanced with 3, 2, unwritten 1, 3. So now that I've got that balanced equation, we can look at the actual problem. And what I always recommend to my students is label the problem. Okay? So as we go through this, if 5 moles of Mg, that is what is referred to as a starting amount. Okay? It's the amount that they give you in the problem. And if you're going to work a math problem, there has to be a starting amount. So it tells me 0.5 or 5.00 moles magnesium are reacted. How many? That's my question, and it refers to moles of H3PO4. So what I do is my starting amount, I call that substance A. What I'm trying to find, in this case H3PO4, that is my substance B. And I label those within the balanced equation, because when we go to look at the ratio of moles, it's going to be important that we know from the balanced equation what is substance A, what is substance B. So looking at the mole roadmap, again, we are starting at moles of A. This is our given amount. So if we're thinking about this in terms of given versus wanted, we're given moles of A and we want moles of B. So this is the only portion of the mole roadmap that we actually are interested in for this problem. So all we need is that balanced equation. So setting this up, I start with my starting amount, so 5.00 moles of magnesium, and then my open parentheses. And if I look at the mole roadmap, I need moles of B over moles of A. And that's why I've labeled these as A and B. So in my balanced equation, it shows that there are 2 moles of my substance B, which in this case is H3PO4, over 3 moles of my substance A, which in this case is magnesium. And again, my hope is that eventually you won't need the mole roadmap, that you can instead look at this in terms of units and recognize that if I start with moles of magnesium, in my conversion factor, I need moles of magnesium in the denominator. That way, moles of magnesium as units will cancel out, leaving me with moles of H3PO4, which is in my numerator. Now, all I have to do, like always with the conversion factor, is multiply by what is in the numerator, divide by the denominator. So 5 times 2, and then divide that by 3. And what you will calculate is 3.33 moles of H3PO4. And that's our final answer. And I've written it as 3.33 because our starting amount had 3 significant digits. So we always want to make sure that when we're doing mathematical problems, quantitative problems, that we pay attention to our significant digits. So that is a mole-to-mole problem, one of the simplest type, which, by the way, again, want to mention, if this had been 5.00 particles and they asked for particles, again, these 2 steps simply cancel each other out, and all I would have to do is multiply by 2, divide by 3. So that's why those are grouped together in those 4 general types that you're going to run across. So that's moles to moles. So let's look at now moles of A to grams of B. So we're adding in the concept now of a molar mass. So as I go through this, again, we always want to label. So if 5 moles of magnesium, so I'm going to start with that same 5 moles, and whatever my starting amount is, that is going to be my substance A, are reacted, how many, so there's my question, grams of H3PO4. So H3PO4 is what I'm trying to find. So that is my substance B. And if I think about the roadmap, I'm given moles of A, and now I want grams of B. So all I'm going to need is this section of that roadmap. So let's go on and work this problem. So my 5 moles of magnesium, 5.00, not grams, sorry, getting ahead of myself, moles of magnesium. My first conversion factor, again, I want to cancel out moles of magnesium, which means I will need moles of magnesium in my denominator. And according to my balanced equation for substance A, there are 3 moles. So my 3 moles of magnesium, which again matches what the roadmap tells me, moles of A from that balanced equation in my denominator, and then moles of substance B on top. So my substance B is my phosphoric acid. And again, the equation tells me there are 2 moles of that H3PO4. I can close the parentheses. And just like I've mentioned in previous video when we were doing mole conversions, I could solve this right now and get an answer. Okay, this would be that 3.33 moles H3PO4 that we found in the previous problem. But instead of typing this into my calculator, hitting enter, and then having to start a second problem for the second step, I go on and string these together. So my second step now, since I've done my moles of A to moles of B, will be my moles of B to grams of B. And this is where I am now going to need a molar mass. So you can see on this roadmap, molar mass per 1 mole. So when you calculate the molar mass of H3PO4, just as a quick refresher, if you have done this before but just don't quite recall and don't want to go back and look at those videos, then we list out our elements. I have 3 hydrogens, each with a mass of 1.01 from the periodic table. I have 1 phosphorus, where phosphorus has a mass of 30.97. And I have 4 oxygens, where each has a mass of 15.99. So I would do the multiplication, and then I'd add up each one of these values. And what I find for the molar mass of phosphoric acid is that there are 97.96 grams of H3PO4. And because it's a molar mass, that is always per 1 mole of that particular substance. So now I note that my moles of H3PO4 cancel out. The only unit remaining will be grams, and it's of the H3PO4. So when I calculate this problem out in my calculator, again, we're going to multiply by our numerators, divide by the denominators. So 5.00 times 2 divide by 3 times 97.96, and I get an answer of 326.53. So as a result, this is going to round up to 327 grams of H3PO4. And again, I've rounded to 3 significant digits. So now I know that if I have 5 moles of magnesium, I'm going to need 327 grams of phosphoric acid to react with this. Okay? So that is a moles to grams problem. So let's look at the next type. Grams of A to moles of B. This is pretty much what we just did, but in reverse. Okay? So let's take a look at it. If 5 grams of magnesium, again, we're going to label if 5 grams magnesium, that's my starting amount, so I label that as substance A, are reacted how many, there's my question, and it refers to moles, of H3PO4, that is my substance B. So looking at the mole roadmap, now I am given my grams of A, and I want moles of B. So we set this up. Again, my starting amount is where I'm going to start. So 5.00 grams of magnesium. And if you look at the roadmap, it tells me 1 mole per that molar mass. So all I'm looking at for the roadmap is this portion that I've just put in the box. So 1 mole per molar mass. Or again, hopefully eventually you'll get to where you don't need that roadmap and you can recognize that I need grams of magnesium to cancel. So in my denominator, I would need grams of magnesium. In my numerator, this would be 1 mole of magnesium. And the molar mass of magnesium, when you look it up on the periodic table, is 24.31 grams. So after my first step, converting grams of A to moles of A, grams of magnesium would cancel, leave me with moles of magnesium. Now for my second step. So this is going to be my moles of B over moles of A. So again, I can go to the periodic table and say, okay, my substance B has a coefficient of 2, so I would need 2 moles of that H3PO4 over moles of A. On my balanced equation, my moles of A are 3 moles of magnesium. But if you're not using the mole roadmap, again, the logic should be that you need moles of magnesium to cancel. So since in step 1 they're in my numerator, step 2 they would have to be in my denominator so that they cancel. Again, at this point, I will have solved for my moles of substance B. And that's what the question is asking me. So in the calculator, again, we're going to multiply by each of our numerators, divide by each of our denominators. So I type it in 5.00 times 1 divided by 24.31 times 2 divided by 3. I hit enter and I get an answer of 0.137, and the only units present are those moles of H3PO4. So that's my final answer, and it's to the correct number of significant digits. So that's grams to moles. So now then, only thing that's left, grams all the way to grams. So if 5 grams of magnesium, starting out that same 5 grams, that is my starting amount, substance A. So I label how many, there's my question, grams magnesium phosphate, that's going to be my substance B. Okay. Now notice I've kind of switched this up because I've been using in these other examples my H3PO4, and that's been my substance B each time. Well, anything within that balanced equation can be your substance B. So in this case, I've switched it up on you, and I'm asking for grams of magnesium phosphate that can be formed. So don't get stuck into the idea that the first component has to be A and the second component has to be B. Okay? If you're balancing equations algebraically, like I show in one of my previous videos, after you're done balancing, go back and erase the letters above each substance so that you're set up now for the stoichiometry and you can move A and B around. Okay? But in this, I am given grams of A and I want grams of B. So the portion of the roadmap I'm using is just this up here. And please recognize that in any of these problems, I'm starting with grams, but I just as easily could have started us out with particles to calculate moles. And then we're right back onto the main road of this roadmap. Okay? I've chosen to just start each one with grams and deal with molar mass rather than Avogadro's number. But in this problem, here's what we should also notice. We're going to have a step 1, step 2, and a step 3. Again, while you could work 3 separate individual math problems, it's easier to string them together. That's what we're going to do. So 5.00 grams of magnesium is my starting amount. So my first step is going to be going from grams of A to moles of A. My roadmap tells me 1 mole of my substance A, which in this case is magnesium, over its molar mass. Molar mass, again, from the periodic table is 24.31 grams of magnesium. And if you're not using the roadmap, again, you should recognize that in my conversion factor, grams magnesium need to be in the denominator so that those units cancel out, leaving me with moles of magnesium. So that's step 1. Step 2 is where we're going to go from moles of A to moles of B. And again, if we're looking at the roadmap, moles of B, so my substance B in this case is my magnesium phosphate, and it has a coefficient of that unwritten 1. So there would be 1 mole of magnesium phosphate that is produced over my moles of A. So this would be 3 moles of magnesium that is reacted. That would take care of my step 2. And again, notice, moles of magnesium in step 1 cancel moles of magnesium in step 2. So now for step 3, where I'm going to go from moles of B back to grams of B, and now molar mass per 1 mole. So the molar mass of Mg3PO42, when I calculate it up, is 262.79 grams of Mg3PO42, and that's going to be per 1 mole of Mg3PO42. And I have my students ask a lot of times, do we really have to write what the substance is? And I tell them, yes. Because if all I'm doing is writing down the numbers 1 over 24.31, 1 over 3, 262.79 over 1, it's very easy to lose track of what substance it is that you're working with. Not only that, but by writing down the substance, again, we can visually see that between step 2 and step 3, my moles of magnesium phosphate cancel out, and that's exactly what I want to have happen. So if it's only numbers, you can't really verify that units are canceling like they're supposed to. So I always tell my students, yes, write down those substances, verify the units. Because if you're a student that struggles with math and with conversion specifically, having those units on there and seeing how they cancel out can really help guide you in the process. And again, my goal is that eventually you won't need the mole roadmap. That instead you can look at this strictly from a given want perspective and see how the conversion needs to be set up to cancel out those units. Okay? But as far as mathematically working this, again, we're going to multiply that starting amount by each one of our numerators divided by each of our denominators. So in my calculator, I would type in 5.00 times 1 divided by 24.31 times 1 divided by 3 times 262.79 divided by 1, and then hit enter. And what I find is I would produce 18.0 grams of Mg3PO42. That's my final answer to the correct number of significant digits. So here's where I want to point out why stoichiometry is so important. If I go into the lab with 5 grams of magnesium and I have, what we call excess phosphoric acid, where I'm going to use up all of my magnesium, all 5 grams, I know that I should be able to produce 18 grams of that magnesium phosphate. So we can run the reaction, collect the magnesium phosphate, and then mass it and see if we actually produced 18 grams. It's a way for us to have some quality control to verify that what we're doing is what we say that we're doing, mathematically and physically in the lab. So that's why chemists need stoichiometry. We don't want to go into the lab and just throw things together haphazardly and hope that we get the right amount. We use stoichiometry to solve that out. So here is a practice problem for you. If you want the answers to this, leave me your answers in the comments, and I will get back to you as to whether or not you've calculated them correctly. If you don't calculate them correctly, then we can start a conversation there and figure out where you might be getting off track. But there's an example problem for you. Good luck with it, and again, feel free to contact me if you do run into difficulty. All right. Last little thing on this before I close out the video. This is that complete roadmap that I told you at the beginning of the video I was going to show you. And in this, the reason why I didn't show you the liters or the volume, this is for gases only. And this does not refer to liters of a liquid. This is for gases when they're at what's called standard temperature and pressure. And if I'm asking going from liters to liters, again, notice those 2 steps would cancel out. So all I would need is my mole ratio from the balanced equation. Okay? But if I'm starting at liters of a gas, I can convert to moles, moles to moles, and then back to liters, grams, or particles. If I'm starting at grams, I can go to moles, and then to liters, grams, or particles. Likewise, if I start at particles, I can convert to moles, my other substance, and then to liters, grams, or particles. So it doesn't matter what we're starting with, where we're going. And if you've watched my previous video, I have told you that this grams to moles, we follow this rule of SWAMA. And when we're going from moles to grams, that is also SWAMA. Start with 1 mole always. Well, that middle step, that's a ratio of moles. So if you ever hear a professor talk about SWAMA, ROM, SWAMA, this is what they're talking about. Start with 1 mole always. Notice that in each one of these, it's 1 mole. We then take a ratio of moles, that's your ROM, and then we start with 1 mole again. So SWAMA, ROM, SWAMA. So if you have any questions, you have any comments, please feel free to leave them for me. I will get back to you. I hope that you have found this video helpful. And as always, thanks for joining me. Take care.